All right, I'm going to start with the problems that I left for you on Monday. Yesterday, you had to watch kind of the new material, um, starting with different denominators and just kind of covering of everything with those fractions. But let me answer the ones that I had you add and subtract the fractions with the same denominator and then reduce when necessary. So the first one we had 2/7 plus 3/7. Okay, so if the bottoms are the same, you just add the tops and you get 5/7. That does not reduce. There's not a number that goes into both of those, so it's just 5/7. Then 1/6 plus 2/6, same thing, just add the tops. Okay, the denominator stays the same. And that does reduce down. You can divide both of these by 3 and you get 1/2. Okay. Number 3 is 4/9 minus 3/9. Okay, so you just do 4 minus 3 and you get 1/9. That does not reduce down. So subtraction is just like addition. Just do the tops, keep the bottom the same. Number 4 is 7/8 minus 5/8. So you get 2/8. And you can divide both of these numbers by 2 and you get 1/4. Okay. Then I had a couple bigger ones. I had 60/80 minus 20/80. Okay, so you get 40/80. Okay. And if you have to go through and figure out what you can divide those by, you can. If you had to go down by 2s. Also, if you can look and see that both of these are divided by 40, that goes into 40 once, that goes into 80 twice, so it eventually should reduce down to 1/2. So if you went down in pieces, it should get down to 1/2. Okay, this one was 36/48 plus 10/48. So you're going to get 46/48. So this may be one that you got to work your way down. So let's divide them by 2. Because they're both even, so you know you can divide them by 2. This is going to be 23. This is going to be 24. At that point, maybe you could look at your multiplication chart, see that there's nothing I can divide into both of these. And so that is my final answer, 23/24. So check your work on that. Go through that. Hopefully by now you're seeing the pattern of what you're doing with those first part of the fractions. Okay. Now, as far as going a little bit further, I had you watch the videos on the common denominator and what happens when those denominators are not the same. I wanted to kind of do some introduction with that, and then I kind of want to put my spin on it, just so that you see a little more explanation. This will be the most challenging thing you do of the Math Lab class, obviously, is working with fractions, and especially when the denominators are different. But let me put this up here and show why we have to have the same denominators. Let's say I was adding 1/2 and 1/4. Now I want you to think about like in a baking world. I did that with the little cups and stuff. Think about having half a cup, okay? You have half of a cup. And then you're going to add in another 1/4. So you're getting pretty full. You're getting pretty close to a cup now, okay? Because you're not, you've got half a cup and then you put in a 1/4. So you're getting pretty close to a full cup. Well, if all I did was add the tops and add the bottoms and then reduce that down to 1/3, this would be wrong, because 1/3 is even less than 1/2. So there's no way you could start with a half a cup, pour some more in, and end up with less. So that's why we can't just add the tops. Same with money. If I had half a dollar or 50 cents and added a 1/4, okay, and had 75 cents, there's no way I'm only down to 30 some cents, 33 cents. So that's why you can't just add the tops and add the bottoms when the denominators are different. Okay, so I wanted to highlight that to always show that there's a purpose why we have these rules. Now, let's go back to this one, 1/2 plus a 1/4. I think what the videos do, and it's really no set way. You're going to find out now as you're getting into math, as you go further especially, there's not always one way to do things. And so I've always been a teacher that as long as you get them right, I'm not necessarily concerned that you do them different than I do. Now, if you keep missing them, I always try to encourage you to, well, try the way I did it. You know, get used to where you can watch that and then do it that way and see if that come out more consistently for you. But you know, I always know there's more than ways, and sometimes some ways work better for others. Now, some of the videos talked about easiest common denominator or like just common denominator. And what they do is, and I've even seen some teachers teach it this way, is they just so my goal is I'm going to make a new fraction here, I'm going to make a new fraction here. And by new, I'm not going to change these values. Okay, it's not like I'm turning this into a totally different value. And same thing with this one. So this fraction, I'm going to make this one, this fraction, I'm going to make this one, and then be able to add them. What I don't, you know, want us to think though is I'm changing the values. So kind of think of it as the reverse of reducing. So think of all the ways this could be. This could be 4/8. It could be 50 over 100. Remember we talked about that's the same as a half. You know, if you write a check and then you're writing half a dollar, you can write 50 over 100. So, and instead of reducing, we're going to expand. We're going to make it bigger, but we're going to keep the value the same. So this could be 4/8, it could be 6/12, it could be 8/16, as long as it reduces back down to a half. But I'm going to expand it out. Well, what some methods teach you is to get the new bottoms for both of these is to just multiply 2 times 4. So when you multiply 2 times 4, you get 8. So we're going to make our new bottoms 8 for both of these. And that's fine if you want to do it that way, but I'm going to show you a problem with that method. So if you do that, you do 2 times 4 and you get 8 and 8. Now let's just look at this fraction alone. Let's just look at this one and say if I expanded this out, what is this new fraction? Well, we already know half of 8 is 4. So it would expand out to 4/8. But this gets harder when it's not just perfectly a half. So what you do is instead of thinking of it that way, think, what did I multiply this by to get 8? Okay? And so I got to multiply the top by the same. So if I multiplied, and that's just by dividing, if I divide 8 by 2, I figure out that I multiplied the bottom by 4. Well, now I have to multiply the top by 4. Okay? So let's look at this one. If I multiplied 4 by 2, then I got to multiply the top by 2. Okay? So that's my new fraction there as far as it expanded out. Okay? And that's okay if you do that this way. However way, even in the videos, they offer a couple different ways. Now what we have is now we can add these together. Okay, now we forget about this. We're just adding 6 up top and we keep the bottoms the same. And then we know that reduces down to divide them both by 2 3/4. Now think about that to our original problem. 50 cents, half a dollar, plus a quarter. So we should have 75 cents. 3/4 is 75 cents. So that's how you can do that and get to that answer. Now here is, so in this way, let me go back because I got a lot of writing here, and there's no way you're going to want to write that much each time you do this. But in this way, you just multiply the bottoms, and then you go from there. Okay, you expand this fraction out, you expand it, and then you add. Problem with that is you may end up with a problem that is much bigger. So let's look at what happens. Let's say if I'm trying to do 6/7 plus 11/14 or something. Okay, in that case, if you're doing this that way, you have to do 7 times 4. So your new bottom is going to be 84. You're going to have some very big numbers if you do that. And you're going to have big numbers up here. It increases the chance of making mistakes as your numbers get bigger, especially when you go to reduce then. I tend to lean towards where you should try to find what we call the least common denominator on these problems. Okay, least common denominator. Because at that point, you're keeping your numbers small. Now, in order to find the least common denominator, what you're trying to find is, you're trying to find the smallest number, okay, that's what least, that both of them, so that's where the common comes in, that both of them will apply to, that you can get the bottoms the same. So you're trying to find the smallest number that both these numbers go into. Now how you could use your multiplication chart, so let's take a multiplication chart. Let's say we're looking at 2, 3, and 4. Okay, and 2 times 1 is 2, 3 times 1, just to give you an example of what a multiplication chart looks like. You know, it's got this thing here where it goes through, and then, you know, 2 times 2 is 4, 2 times 3 is 6, 2 times 8, and so on. We keep going here. Okay, let's go a little bit further. Let's go one more. Okay, and what I did was, you know, 2 times 1 is 2, 3 times 1 is 3, and that's how a multiplication chart. Here's your multiples of 2, basically. 2, 4, 6, 8, 10, 12, 14, 16. Multiples of 3 I put in there, multiples of 4, 4, 8, 12, 16. What you're trying to find is the smallest number that both 2 and 4 go into. So we don't even have to worry about 3. We're looking for the smallest number that 2 and 4 go into commonly. Well, 4 doesn't even go into 2. Okay, so it's got to be bigger than 2. But we look, 2 goes into 4, and 4 goes into 4. See, if I use 8, that's not my least common denominator. There's actually one smaller. Okay, it's the smallest number that both of those go into. So in that case, the smallest number that both of them go into is 4. Meaning this one expands out to 2/4, and this one didn't even expand, didn't even change, so I don't change the top, and I have 1/4. So now when I go to add these, I will get to 3/4 much quicker than when I had 6/8 and had to reduce down. And you say, well, it really wasn't that easier. Why did you do that? Well, let's go back to that one I was saying was harder. Okay, 6/7 plus 11/14. Okay, if I go to multiply these, I'm going to have 84 and 84. Those are big numbers. Instead, I can think, what's the smallest number that both of these will go into? Well, the smallest one that both will go into is 14. 14 goes into 14, and so does 7. Now, when I go to expand these out, what did I multiply 7 by to get 14? Well, I multiplied it times 2. Well, do the same thing at the top. This now is 12/14. And what did I multiply 14 by to get 14? Just, it stayed the same. You multiply it times 1, so the same thing, it stays the same. And now, you add the tops, you get 23 over 14. Okay, 23 over 14. Had I done it the other way, so had I done it by multiplying the two bottoms, I would have got 84. I would have had to multiply this by 11, so I got to, or sorry, 14. So I got to multiply this by 14, which is, no, it's not even 84. Sorry. I was trying to go too quick. What was my original 11/14? So it's actually 98. 7 times 14 is 98. So I multiply this by 14. I got to multiply this by 14. That's where you get 84. And then here, I multiplied this by 7. So I can multiply this by 7. I get 77. And now I've got 11, let's see, 161 over 98. Now, eventually, if you reduce this down, you will get to 23 over 14. But you can see those are some big numbers, and it's going to be really hard to reduce that. To me, it's easier to get used to this process of finding least common denominator to find those bottoms. Now, let me do some and practice it so that you can see it over and over, because I think repetition will help you. If you want to pause as I do each problem and try them on your own to see if you're coming up with the same thing, that would be a good idea. So let me add 2/3 plus 1/4. And sometimes the least common denominator is the same as just multiplying, but it's a lot of times it's not. But in this case, the least common denominator, the smallest number that both these go into is 12. Okay. that means this is going to change to 8 because I multiplied this by 4, so I can multiply that by 4. And this fraction I multiplied by 3, so I got to multiply that by 3. Add them together, you get 11 twelfths. Okay. Let's look at 5/6 minus 5/12. Let's do a subtraction one. Now this one, if you multiplied the 2 to get the easiest, it's going to be 72. That's going to be your bottom. That's a big number. But if I figure out that 12 is the smallest number that these go into, okay, and I keep it a subtraction problem, then this one doubled, so I got to double the top. This one didn't even change, so I don't change the top, and I do 10 minus 5, and my answer is going to be 5/12. Okay? I just did the 6/7, 11/14. Let's do, oh, okay, let me do that one again. So, well, I don't have to do it again, but here was my answer. Sorry, I keep jumping around, but let me do one more of a least common denominator. Let's add 1/3 plus 2/9. Okay? If you multiply them as 27, there's a smaller number that both these go into. That is 9. Okay? 3 times 3 gave me 9, so I got to multiply the top by 3. And this one didn't even change, so the top stays the same. And I end up with 5/9. Okay? So go back through those, try those, see if that's what you're coming up. If you're doing it as easiest common denominator, as long as you're coming down to 5/9 at the end, then we're okay. Okay. One thing I do want to show you is, we talked about reducing, but we didn't really hit on, well, what happens when we end up with that bigger on top. That is called an improper fraction. And really, when you are working in math, a lot of times you are not going to leave that as improper, meaning bigger on top than bottom. You're going to turn that into what we call a mixed number. Okay? Now let me give a smaller thing first. Here's a improper fraction. Well, how do you turn that into a mixed number? What you have to do is you have to see how many times 5 goes into 7 without going over, and go through this whole thing. And you think, well, whoa, that's a lot of extra work. It's not. Remember, we can rewrite this as 7 divided by 5. Well, if you do 7 divided by 5 and write it out like we did with long division, remember we did, how many times does 5 go into 7 without going over? Once. Okay? I had a remainder of 2. Well, how did we turn that into a fraction? We took 2 and put it back over 5. That's how you turn this into a mixed number. You say 5 goes into 7 one whole time with a remainder of 2 over 5. So that is a mixed number. Let's try it with this one. 14 goes into 23 one time without going over. You had a remainder of 9 back over 14. Say, how did you do that? Well, you can go off to the side, say it goes one time with a remainder of 9 over 14. Okay? A couple other of those. 4/3. Now think about that, 4/3. If you had 4 of those third cups, you would have a full cup, 3 goes into 4 one time, with a remainder of 1/3. So you would have, 3/3 would give you a full cup, and then that 4/3 would be the last third for that. Okay? What happens when it divides evenly with no remainder? Let's say you have 20 over 10. Well, remember this is just 20 divided by 10. Remember this is division symbol, 20 divided by 10. Well, what's 20 divided by 10? 2. There is no mixed number, there's no left over, there's no remainder. This just turns into 2, and you need to do that. So like 8 over 4, same thing. 8 divided by 4 is 2. Or 6 over 2. 6 divided by 2 is 3. Okay? So if you have that improper and it comes out even, then that's where you can leave it. Okay? What happens, one more example. if you've got 14 over 4. Okay, 4 goes into 14 3 times without going over. Okay, I can check that out. 3 times gives me 12. My remainder is 2, so I put that back over the 4th. Okay, 2 over 4. And you still are responsible for reducing this fraction part down. So this is not going to reduce. This doesn't change. It's not a fraction. This will. It reduces down to 3.5. Okay. 2/4 turns into 1/2 when you reduce. I know that's a lot of material. Go back through, watch it. If you need to even look up some of this, like turning improper into mixed, or least common denominator. There's so many videos, so many different resources that you can look at for that. Let me put your assignment so that you can get some practice with this. I have you do 2/3 minus 1/2. Make sure you're reducing these as well. 5/7 plus 1/14. 5/12 minus 1/6. 5/8 plus 3/4. And 2/3 plus 7/9. Okay? So go through and do those and see what you come up with. You can check them on the next video. Okay?